Hi, so for some of you who don't know me, I'm Soona Amhaz, co-founder of Token Daily, a community platform and newsletter where we keep you up to date on the latest in cryptocurrencies. So if you want to subscribe, we'll wait. So today I'm joined by a few people who spend a lot of their time thinking about smart contracts and building. And how about you guys introduce yourselves?
Sure. So, well, first, thanks for having us. I am Martino, co-founder of Kadena. We are a blockchain, base layer protocol store value approach to solving the problems in smart contracts and also scalability. Before Kadena, my co-founder and I led the blockchain team at JP Morgan and deployed their first eternal blockchain internationally between London and Tokyo. And before that, my intro to crypto was actually at the SEC when Valerie started the cryptocurrency working group. She needed a tech lead, and I raised my hand because I didn't own any coin and wanted to be in the room to shout, "Oh my God, don't ban it."
Tom. So I spent the last 5 or 6 years in crypto. Co-founded a number of, most recently Definity. Before Definity was a synthetic asset project. I believe it's probably one of the world's first decentralized exchange. Which is probably way too ahead of its time, but now it'll be interesting to see how it goes. The other thing that I'm pretty interested in is how to use crypto to accelerate things that are outside software. I think crypto did a fantastic job in accelerating to create the biggest open source movement in history. It's the first time when open source developers are no longer broke and worried about paying bills, right? We're all pretty well funded now. What about outside software? Since I'm particularly fascinated about using crypto for funding life science specifically.
Hi, my name is Jon Choi. I was working at the Ethereum Foundation until last month. I focus on research and community grants. Prior to Ethereum, I worked at the industries that were trying to disintermediate. So I've been a debt banker in Wall Street, as well as working on storage infrastructure at Dropbox. And while trying to work on a startup, I realized that it was kind of depressing to work on a startup, knowing that the goal is to get acquired by Google or Facebook, to be honest. And I kind of stumbled into crypto, and that's how I kind of fell down the rabbit hole.
Thanks, guys. So let's start in the beginning with the origination. In Szabo's 94 paper, he initially mentions an encoded smart contract, and then we fast forward and we see it popularized around Ethereum and Rootstock. But since 2015 and 2016 till today, what are the major ways you guys have seen smart contract technologies evolve?
I'll give it a start. The major ways since 2015 and 16, I think part of it was I remember being in JP and trying to get Ethereum to work for institutional enterprise use cases, and it demonstrated a bunch of needs that I don't know if were quite clear when it was first generated. Having upgradable contracts, for example, or maybe the needs for formal verification not being so readily apparent. And since around then, we've seen a lot of movement towards either verified virtual machines or almost in two different directions. One being that it's more towards safe generalized computation, and the other being more towards safe representation of value.
Can you explain what those are for the non-technical folks in the audience?
Sure. So there's part of the way that I see the way that smart contracts are evolving is that there's kind of two different schools of thought about what the core of it is. One is about just censorship-resistant decentralized computation, and that as the fundamental thing. And the other one kind of harkens back more to Bitcoin, where at the base you have value, and then the reason that you would do this incredibly expensive thing of this, executing a smart contract, I think it's one of the most expensive substrates to run a computation on, is that you have something more valuable sitting behind that computation. And that computation is decentralized and has all these other features, but the point is that it's protecting something more valuable behind it. So those are the two when I'm talking about decentralization versus it just being. That's enough.
Tom and John, which school of thought do you guys subscribe to, or do you find another reason behind smart contract computations being expensive and also how they've evolved?
I would want to think slightly differently from, so apart from the tokenization kind of aspect, which everyone is very familiar, which by the way is still massively under-tapped kind of a thing, but I'll put aside for now. The other thing that are really interesting is when you think about smart contract in general, the trust model is that it's typically trust of N. We don't trust one person, we don't trust one miner, so we want a lot of miners to mutually verify, etc. Moving up the layer, it could be a lot of financial validators who validate a single loan. It could be multiple gamers, game developers who validate the same transaction, etc. What about the one that hasn't been talked enough is you trust of one, or N of one. What if we only have one corporation? So I was in a weekend retreat recently about crypto for good, and there was a massive, half of the discussion was about the failure of the public trust from the major consumer tech corporation, Facebook, Expedia Data, Uber, et cetera, et cetera. So I was thinking about what if crypto could actually help them improve trust as well? And that's more from a technical standpoint. The fact that you have created a state machine that logged every transaction and the state changes, perhaps it would be interesting to think about less of a kind of a fundamental shift like Facebook, you decentralize everything internally. That's probably too much of an ask, honestly, to be a massive, giant corporation to transform business model overnight. A more reasonable ask, perhaps, and for their own benefit, is they say, okay, we have certain part of our EULA, right, end user license agreement, which no one reads, thousands of pages, that defines our contract relationship between you, the consumer, and us. And we're going to up that EULA to a more friendly one. In order to make sure that you can trust us, we actually exit EULA. We're going to convert some point of that, such as we're going to forget your data after, let's say, 90 days you delete your Facebook data. We'll put that in an internal container that runs like on a state machine kind of structure. I haven't thought very deeply how technically that would work, but I can see that run on that thing. In order to make it more public attested and trustworthy, you perhaps want a crypto company, even like Coinbase. Instead of thinking Coinbase as a custody of your financial asset only, think of them perhaps as a custody of state and logic. And they could be one of the nodes or whatever for a massive corporation. So these are interesting things to think about the trust at the end of one problem. That's a trust property. The other side of the property is about efficiency. In Definity, we think a lot about, we don't call them smart contracts, right? We call them decentralized processes. And that's, I think, is a better way of describing the technical efficiency of it. The traditional corporate IT structure are massively complex today. You have Amazon Web Services with like 10,000 services on AWS homepage, right? And it stems from the complexity just of the machine itself. And there's a chance, I think, right now to collapse the entire stack to a much, much thin layer, that you run these decentralized processes that are tamper-proof, supposedly unhackable, theoretically unhackable, that are based on PKI, et cetera, that could be way more efficient. So even though computationally, they will always be more expensive, right? Let's not forget that blockchain are always 100x or 1,000x or more expensive than strategic computation. This cost saving come from 90% of your human cost. The fact that now I don't need a group of database maintainers and security auditors and et cetera, and the hacks and the loss from the hacks. So that's how I think about the N of one, and then we can expand that model obviously to the N model.
That's great.
Yeah, just to add, I think I agree with Tom that maybe that initial question of saying what degree of decentralization is the right school of thought per se. I think the right question that we don't ask ourselves often enough in crypto is, who is this technology for? And if you ask that question, I think the school of thought becomes very clear. Because I've been recently thinking about how crypto is so exciting because it's such a Cambrian explosion of ideas around who should we disintermediate today. Like one day it's the government, second day it's Wall Street, third day it's internet giants. But to do that, you actually need to make very different trade-offs at the base layer. So if you look at Bitcoin, you really say, hey, how can we not have identity? How can we not have a centralized authority that's settling the transaction? But to do that for the internet, that's a very different need. And the features that you have to optimize for are very different. So I think once you ask that question about who the user is, I think the question becomes super clear.
Absolutely, and I think that's a perfect segue into our next question, which is the value of smart contracts on two levels. One, on an industry level, which industries do you think stand to be quote unquote most disrupted by smart contract tech? And on a consumer level, who's the user that would gain the most value?
So I come from first a enterprise blockchain background, then moving into having an enterprise and a public in our stack. So the easiest way for me to model it in my head is to think about financial either services or products. And I think that there's this big swath of just domains or market sectors that never really digitized. Unlike the internet comes online and then we get fixed income, digital marketplaces for like the 5-year T-bill. And the reason that you do that is because this thing looks the same every single time. Versus, insurance, if you're going to go and insure 2 different skyscrapers, even in the same city right next to each other, those contracts are actually a little bit different. And they have overarching themes that almost entirely overlap, but because they're a little bit different, you end up in the situation where there's not really a marketplace or really a central SOAR settlement layer for it. Instead, right now they're doing either Excel at best or, generally speaking, faxes and emails. So the way that I describe the idea more broadly are the semi-fungible marketplaces, where you have things that look a lot alike, but they're a little bit different, and you need to be able to stamp out custom representations of these things quickly without having to do a whole lift around making an entirely new market just for, let's say, one skyscraper's. Let's say you want to go and tokenize one skyscraper's market. The insurance product there. As for the consumer, my big hope is that, or the people that are going to benefit most from it, my big hope is that we're able to take this notion of being able to give a capability or the authorization to be able to go and access something, the public key signature, but a little bit more complicated, and have that be integrated with existing companies today, so that, let's say I want to go and rent an apartment, I don't need to actually go and physically get my bank docs and give them to go to, let's say Chase, get my bank docs and then bring them to the realtor so that the landlord can actually go and see them. I can actually just sign off on a command that says, okay, go get these docs from here, go get these docs from here for KYC and AML, go get whatever and whatever. I can just hand over the representation of that authorization, and it'll have a time aspect to it, so it'll only be good for 2 days. And then they can just go and run it on the system, and then those things will privately be kind of centralized. It's almost like you can digitize your life more and have less screen time at the same time.
When I think about industry, I guess think a bit more kind of abstract. If you abstract away, you think about there's a public sector and private sector. In the private sector, we have the 2 extreme of the continuum of type of you have the C corporations or whatever for-profit corporation in other countries, and then all the way you have the nonprofit foundation. In crypto, nonprofit, for example, is quite popular. But these are 2 extreme of things, right? And when you think about nonprofit corporations, they serve a purpose typically for the public good, but they're governed very differently. They also don't have the idea of shares, for example, which mean that you're driven to do potentially other bad things, harm to the public benefits. So you wonder, could smart contract actually serve as I would consider a kind of a very different use case from which to talk about is a public corporation, a publicly verifiable open source corporation, in which it serves a public good, but that can be profitable too, but based on rules. Here's a concrete example. So I think a lot about, for example, in life science, there's a massive need for data, for collaborative data. We wanted to crowdsource a large group of genomics, epigenetics, all kinds of human biomarkers that will massively advance humans' study about lifespan and research. How do you create that kind of thing? Typically, the incentive structure is very skewed. Your Pfizer or Merck, et cetera, they want to collect their proprietary data. Sometimes you have government-funded initiative, but they want to support only their local communities and cities or country, like UK Biobank, very kind of nation-specific. What if you can create a public DAO that collects these data? Now, the limitation of the current generation of DAO technology is because of lack of privacy, like mostly on Ethereum, et cetera, everything's public. So when you think about a corporation has a couple different assets. It has money, it has governance kind of structure, which is talents, then you have certain type of virtual data IPs. So today, basically, you can say a DAO is a more limited, constrained, or crippled version of a corporation because they can't really own data very properly. Whatever data is accrued to DAO, everyone will see it. Everyone's going to download for free. It cannot make it a profitable entity. But once I think the next generation thing, which wouldn't be too far, you have primitive, including Dfinity, Oasis, and possibly Ethereum too, you will get privacy. Once you get privacy, it's impossible to create a container on a public blockchain that contains its own data and its money. And the money, by the way, could even be stablecoin, which would make it even easier gateway to traditional corporations. So now you can create a genomics DAO that says everyone who submit your DNA sample to the genomics DAO gets paid out in token. what that token represents is a claim on the future revenue that any corporation like Merck or Pfizer, whenever they made a paid API call to the DAO, they have to pay a $1,000 stable coin. So you can make these interesting constructs.
So the question was, who are the smart contracts for, right?
Well, on an industry level and consumer level.
I see. So when I think about who should be scared if this technology gets good, is financial services or any slow or inefficient intermediary. So I think smart contracts are one of those misnomers in the industry where people imagine like a piece of paper that's getting put on a computer, but it's not that. Like a smart contract is an autonomous program. So it means that any type of bank teller type situation or interaction that you have where you have to wait for somebody else to check one thing and say it's okay, now that means that if you have an autonomous program, you can have a program that does that interaction digitally. And that means not only do they take less of a cut, but it also means it can be faster. The first order implication of that is pretty simple. Like you have to wait like 5 days less, you pay 10% less. But the second order implication of a network of those programs talking to each other is pretty crazy, right? Because it means that a lot of the kind of imagination that we had around AIs managing processes for you become possible because of the idea of an autonomous program. So I think about financial services. If you look at the 10K, the annual report of Bank of America, JP Morgan, Wells Fargo, Visa, that exactly is the opportunity for economic value to be created from this technology down the line.
Awesome. And well, I was curious, outside of your own projects, what applications of smart contract tech are you excited about today or in the future?
So, I mean, if we're talking about specific projects, then the privacy stuff I'm really into, and think that may end up being maybe trusted execution environments, maybe the how do I put it? The enabling tech of crypto, kind of like the smartphone was for the internet. We're way far away from being there, but at least it's kind of a push in the right direction. Or if someone can crack secure multi-party computation, make it generalized and efficient, that just opens up whole new avenues of interaction. In the meantime, I think the overall idea that I like the most is expanding almost the notion of the sharing economy. So you can almost think of it like a consumer has a car, they don't, normal sharing economy, they don't use it all the time, so you can rent it out and get paid some fee and let someone else use it in the meantime. They have to have the car anyway, so it's just a cost to them when they're not using it. And why not monetize it? Enterprises have the same thing. So a good example is Rent the Runway has the biggest dry cleaning facility in North America, and it necessarily has excess capacity that it's not using. And right now, the way that it's structured, and I know about this because my first hire is from Rent the Runway. Right now, the way it's structured is a bunch of different cron jobs or queries that run that kind of build together the orders or the shipment for clothes to go get dry cleaned at Rent the Runway. And it's kind of this amorphous thing. If you're able to take a smart contract and represent that unit of, like 10 things that can get dry cleaned at once, go and represent that as an actual unit and add them a token, you can have a full view of what is where, how much excess capacity you have, and actually open up, you almost make it like that warehouse is now part of the sharing economy, and you can open it up to maybe a small business that does, prom dresses or tailoring, and has a need for every once in a while doing a large load of dry cleaning, and instead of them going to their local supplier, which is probably more expensive, you can go to Rent the Runway because they have some extra capacity. And then the smart contract ends up being kind of the shopping cart almost, or the on-ramp, or the API or the storefront for that extra capacity that the enterprise is going to share. And it may turn out that because that business actually ends up being a business in and of itself for Rent the Runway, that they can actually expand that warehouse out and have this ancillary thing where they have like 80% of they're taking up 80% of it usually. But instead of having 5% extra just in case, they have 20% extra because it turns out they can actually make decent money off of this because you end up hitting economies of scale when you're already past that point as they necessarily need to be because of just the business that they are.
Yeah, agreed. And it seems all three of you have touched on these decentralized autonomous organizations that you see as a future application of the actual tech. The elephant in the room when we talk about DAOs or DAOs is governance, right? There are outstanding problems in the governance of these actual smart contract enabled organizations or platforms. For you guys, what are the biggest challenges?
So I can take this one. So for governance, I think Will mentioned this before, but I think it's good to separate protocol level governance versus contract governance. But taking protocol level governance first, when I first joined the space, I was very idealistic, and I thought about on-chain governance. So the idea that all the people that are participating in some sort of network being able to very liquidly vote and say, I have 10 votes that are allotted to me. I care about this topic more than the others, so therefore I'm going to vote on this, and instantaneously, like, the election process over a protocol is done. And I realized that that was a bit naive, because there are all these problems around when humans actually get together and cooperate on a collective decision. It's a complex process that includes politics and bribery and things that on-chain governance would be vulnerable to. So I think the problems that are actually unfinished with governance and smart contracts is, how do you actually become practical enough to allow for that human process to really come out, while allowing for the autonomous programs that we were talking about to actually interact with those humans? And I think that's an open question.
I have a little just more on less around the governance itself. There's different ways, liquid markets, et cetera. You can make it better. I thought there's a thought experiment, when we think about the foundation structure. So what if you, instead of having a pure blockchain crypto economic governance versus human governance, what if you can have a hybrid? So imagine a foundation has 3 board seats, and we don't entirely trust the community and crazy algorithmic stuff initially. So we assign 1 board seat or observer seat in the first year. And over time, we can increase the presence of the machine or the community to 2 board seats, 3 board seats, but eventually replacing the entire human organization. I felt like that might be an interesting way. It's partially to give time for technology itself to progress. It's also time for a community to train itself. That, we made some really bad decision last year. Let's try to learn from that lesson. As hopefully, Bitcoin Cash, Bitcoin, all these words. I think each time it taught us interesting lessons, and it needs time.
Agreed. We're quick to have these like, aha, I knew it wouldn't work type of moments when there are bugs or governance structures don't work out as intended, but it is important to remember that a lot of these are experiments running in parallel. I want to turn the conversation to more technical challenges that we're facing. One, I wanted to broadly ask, and then we'll go into more specifics, but what are the major technical challenges in deploying smart contracts that you guys are finding today?
So, I know that we've moved on from governance, but governance is actually one of the bigger technical challenges. As a touch of background, we tried to use Ethereum inside of JP Morgan. My co-founder built a VM for it. He learned a huge amount from that, and he has experience actually building languages for people that aren't developers and are used in production at JP Morgan still. This is how their quant system works for, I think it's agency algo, their agency algo system. But one of the first things we noticed, especially after we left, I think it was the first thing you put into the language that we just redesigned a whole language from scratch. It's an interpreted language. It goes on chain, so the code that you see is the code that is running. And that's one of the challenges, is actually knowing what's running and that there isn't a compiler error that has injected something into your code. But the next thing is being able to see the code, always being able to see. You can never lose the source. That's one technical challenge. But another big one is governance. So when things break, because things will break. We have formal verification in our language. It's for user code, and nonetheless, you will have bugs still. You're human. There's no way around it. How do you actually upgrade things? So I think the second thing he added to the language was when you make a smart contract, you say, I'm making a smart contract. Here's the name, and here's how it's governed. And that is just a function, and you can have it do whatever you want. So it can be let's say it's a quadratic formula is inside of that. That doesn't need to be governed. It's never going to change. But let's say you have, some, a DAO type situation. You can have there be multiple people who sit on effectively like a board, and then also a community vote aspect. And all of this stuff can be run in advance of an upgrade. And the way that it works is that someone proposes an upgrade. That upgrade has a hash. It's just like a normal transaction. And then you end up with a vote that takes place, and the board can come in and say, okay, we approve this thing, and The community's voted on it, so you only need a certain bar. I mean, that's a huge one. I think the final one is contract interop, of contracts being able to import each other in a safe way. Parity multisig demonstrated this very clearly, where people were importing the parity multisig contracts into their wallets. Someone went and poked the parity multisig contract in the wrong place. It broke, and then their contracts broke. And now 200 million in value is, or at least back then it was, is now locked up. And because there's no mechanism by which you can upgrade it besides a hard fork of the actual Ethereum mainnet, it's just kind of stuck.
Yeah, I agree with Will. I think a lot of the challenges in our experience come from like lack of tooling. So we spend a lot of time thinking about like, what's the barrier for developing a web normal web application and a Web3 application or dApps application? For example, there's lack of debuggers, there's lack of IDEs, there's the kind of the virtual machine, which I think is a really good thing happening. I think is the shift to WebAssembly, that we're finally on a common ground. And despite many of the things people complain about EOS, I do think there's some merit to it, is that at least they're using WebAssembly. And they have done a great job in promoting WebAssembly as the first distributed container that people can program upon. I think, so that's probably one interesting angle about it.
Yeah, there are so many technical challenges for smart contracts. I don't even know where to begin.
Yeah.
But so you mentioned WebAssembly. So I think, so just to go back, you mentioned like Szabo and you talked about Ethereum starting, and I think that's a really good perspective to have, because in 2015 when the Ethereum team started, it was really like the cypherpunk movement around Bitcoin that got excited and say, hey, we're getting distributed consensus over a accounting ledger, why don't we do it over a computer? And that was a crazy concept, and I think that really 2017 and 2018 is kind of the hangover from that idea, in the sense that the technical challenges to make that actually work at a larger scale is very difficult. So that means having the right virtual machine environment, selecting the right programming language, having the right tooling, how do we have contracts talk to each other, and the idea of getting consensus over a state of a computer is very different than accounting, because it is path dependent as well, right? So a lot of the problems that we talk about in scalability and privacy is how do you actually have one person that is away from the computation that happened be able to verify that without actually having to run every single thing that the initial computer did, and imagine tens of thousands of computers having to do that across each other. So I think the next innovations will have to come from what are the tricks to make that actually more efficient. So if you have zero knowledge proofs of being able to say this computer that claimed to have done this computation actually did it without having to run everything else, I think that's kind of the crux of how do you make smart contracts more efficient.
Yeah, completely agree. And we have come a long way since. There's still, in order for you to deploy a secure, somewhat complex smart contract, you still need to know how the VM works in depth, which is depressing. But with the advent of we see WASM, we also Truple University has their suite where they allow you to actually do tests and have security verifications and help deployment. But you guys did touch on what you do in the case of, sometimes these things break, right? Smart contracts are mission critical software. In the occasion that something breaks, one, what are guardrails or preemptive measures you take? And then secondly, when it does break, what's the recovery process or damage control look like?
Yeah, so Will already implied this, but there's a lot of difficulties in not only a relationship between a smart contract and the entire network, but how the smart contracts relate to each other. So there's actually not a consensus on what is the best way to do this. Like, for example, if I were to spin up like a Python web app, there's a very simple way to actually split it up modularly and import it, and it's mostly for aesthetics and maintenance. But when it comes to smart contracts that are handling money, it's very difficult to say, well, should I have this entire logic be in one huge file and have to do everything itself, or should I actually relate to other contracts that are already out there and running as independent services? So I think how modular you make these contracts is still an open question. I know teams that have very different architectures around what kind of services they have for one app, and I think figuring that out will be very important.
Yeah. So I totally agree on that, and this is one of the most interesting areas of research right now in how you get these things to talk. Some people are going down the von Neumann architecture route where you're code, and then you like, yeah, you have your contract, and then you're going to jump over to this thing, and then there's going to be some code. That's kind of the parity multi-sig approach and why it broke, because this thing broke. There's another approach which Kadena does, which is that if you import a contract, you actually clone all of the source code into your contract. You actually shove it into the AST, so that if someone goes and changes the upstream dependency, it doesn't actually affect the code that you're running. There's more safety around this, so in case there's like something malicious that's actually a bug that is being leveraged in the thing that's imported to your contract, you can actually, if you're the import, you can shut off access. But it's just a totally different approach, and it doesn't even reflect like a von Neumann architecture. It looks way more like, if you know what a Lisp machine is back from like the 80s, it looks like, at least our public network looks like a giant multi-threaded Lisp machine from kind of a weird perspective, but it actually makes more sense the more you think about it. But leading up to that, you need formal verification, and that formal verification, you need to have that without having a PhD, because I don't know how many people in the room have actually used these systems or worked on formally verifying smart contracts. It's ridiculously hard. Generalized Boolean algebra is kind of the easiest one. That's the SMT family, the Z3 prover, which is the one that we use. And it's still pretty hard to get this thing to work. And I have a math background. So we need to actually, one of the challenges is definitely going to be making formal verification easy enough, at least for part of it, to be used by people who aren't developers. And probably the last bit is just having a language that's really well designed so that you don't have a lot of places where bugs can hide. We've removed Turing completeness from our language because a lot of bugs hide in recursion or loops. And if you remove those, you just remove the shadows that you can have a bug like the DAO, coming back in, or suiciding, or all these other things. You remove the spots where those bugs could actually live, and that makes things a lot safer.
All right, cool. If you want to test it, let's see if you're good to go.
Check.
All right. So our last question for the technical part of this discussion, I was curious what the biggest productivity gaps are between Web 2 and traditional software versus Web 3 smart contract development, if you're going to list productivity tools that exist in the Web 2 world that you wish existed in the Web 3 world.
Like all of it. So, so like the simplest way to look at it is we often say we don't yet have Ruby on Rails for smart contracts. So everyone's recreating the wheel on how to do very simple deployments. So I think we literally have nothing. What we have is like static analysis, and we're still debating what virtual machine is going to win. Are we going to do EWASM or EVM? What programming language are we? If we go to WebAssembly, then are people writing in Rust? If something like Agoric wins, are we going to JavaScript? So I think it's yeah. So it's early to even discuss what tools exist. It's more choose your platform and build tools like crazy.
Yeah, I'm absolutely with you. I mean, even using a VM versus an interpreted language is still open debate. Although I think that I'm the only team that represents the other side of that debate, where we don't actually have a VM that you can't read the bytecode of on the chain. I think that the only experience I have that I think actually I can even use the comment on the question comes out of working with enterprises, because when you end up removing coin speculation from the discussion, you need to have something that makes business sense, and you need to really talk about the full implementation. So we've been working with a Fortune 100 client for over a year, and at this point they're doing full extract, transform, and load to their back end through the POC that they've built up. And so productivity tools was the first thing that they asked for was a native kind of SQL-like query language to be able to actually get the data out quickly for rapid prototyping. And then the next thing was the thing that we had actually already built and we thought that they were just going to use, which is normal database integration. One of the big problems we had at JP, and that's why we built this thing, was that, or this integration, was that getting the data out of a blockchain VM with its database is actually pretty tricky. And we knew that if you're going to have adoption from at least businesses, you would need to have it integrate with like SQL Server, MySQL, Oracle, DB2, all the rest of them. So, some of that stuff, but there really isn't a Ruby on Rails at all. There's nothing even really close.
Or Heroku. Or...
No, it's just, I mean, we did, like Heroku, I mean, a lot of the things that we think about of like having containerized deployments and having different units that are running in different places aren't possible in any of the things that are in production today.
Right. So I wanted to take a quick second to talk about oracles. Oracles sometimes get a bad rep because they're viewed as a single point of failure or a centralized choke point. Recently, we saw some controversy during Augur's good weather, bad weather debate. And it beckons the question, how dependent will we be on oracles, and what's the state of oracles today, and where do we need to go for them to not be viewed as a threat?
Well, so I'll start, but Will actually we had a small conversation before this, and a great example that stuck in my mind is how Bloomberg already serves us for financial services, right? And I think that the way that I think about it is, of course, like if you have a smart contract that says trigger a escrow payment at some point if Apple stock hits Y, or if the weather in San Francisco is Z, is dependent on an oracle. But I think what's really unique to think about is the state before and after smart contracts. So before, you trust somebody to both be the data source as well as the execution of that contract. But in the future, you have a modular architecture where the person or the thing that is executing that contract versus the data source for that are separate. And I think like checks and balances are a good thing, so I'm really actually excited about that.
Yeah, I would also think that there are, I think part of, I wouldn't too against like having a centralized oracle, just because there's certain, so here's an example. So I think a lot about like the life science problem, and one of the application is you could create, for example, a prediction market on how fast we're going to progress on the science. So imagine something like a longevity index, right? And that's an interesting prediction market operation that could settle on a buy oracle that provides the latest intervention. I think the value of that kind of thing is that while the oracle may settle periodically, for example, annually or biannually because of the cost of the overhead of the operation, you could still have the public converge under an opinion about what is the progress of that specific technology. So,
yeah, oracles are going to be big money enterprises. I think that one thing that people forget when with this movement to this next internet, quote unquote, almost whatever this thing is that you can actually monetize public data in a way that makes a lot of sense, which is that the blockchain, you can't, when you're inside of a blockchain execution environment, you can't go query Google for data. Meaning that if you want some data to be live and in part of the business process that your contract represents, it needs to be present on chain beforehand. Even if it's just, what was the score of the, I don't know, I'm terrible with sports, the Patriots game at some point, I don't even know if we're in the season. But let's just say
Take a different example.
Yeah, I'm terrible at these. Yeah, what was the score of the Patriots game last week or something? And you can just go onto Google and type it in, or go get it from a million different places right now. It doesn't cost you anything. But if you're on a blockchain, someone has to actually be keeping that data live on the chain, and they can monetize around that. So you have this way of, in a single like even though people who are replicating a full node have the data themselves on their servers, in the decentralized censorship-resistant context, you actually can get paid for this otherwise valueless data.
Well, speaking of things that are forgotten or fly under the radar, I wanted to go back to the '94 paper real quick. And I wrote this down because, and Tessa's mentioned before, the worst thing that you could do at a conference is get something wrong. So I wrote this down. In his '94 paper, Szabo states, and this is a line that flies under the radar and people don't pay as much attention to, but he says, to communicate transaction semantics well, we need good visual metaphors for the elements of the actual contract. Some people argue that the visual elements component is the biggest barrier that we're facing to mass adoption, and one of the biggest facilitators of bugs. What are your guys' opinion on the visual elements, and like what projects are we seeing in this space that are helping us close that gap?
So I've never really been a big fan of the idea that visual programming is going to save bugs. It definitely helps with some adoption, and there's not a huge amount of prior art on this. The only stuff that I can really look to are two different things. One is SQL. It's not uncommon for a marketer, an advertiser, a salesperson to go and learn SQL and run queries regularly. It's not common, but it's not uncommon. I actually ended up teaching my friend at Shutterstock how to do it. And he does the work of effectively 3 people at this point, and he didn't do what I did, which is tell people that he's learned to program after he learned to program at his job. I got fired for that once. That was fun. He isn't a programmer, but can still use this stuff. And that is kind of the point of the visualization system. And there's some evidence to say that you can actually design a language in such a way that a technical non-developer can learn it and use it, and it can be democratized to a much broader audience. Excel's the other one, where a developer learns Excel very quickly, but a bunch of people who are technical and don't program can use Excel very effectively.
Yeah, just to quickly add, I think the better question here is around the tooling and not the visual language, because no one ever said, hey, email's not going to take off because people don't know how to read SMTP, or Uber's not going to take off because people don't know how to read the GPS API. So I think that's not the right way to think about it.
I do find it interesting, maybe a little bit tangent to your question, but things like open law, I don't know if anyone heard of that project. It's I think Consensus kind of initiative. There's always this interesting discussion ongoing.
Do you want to describe it for people who aren't familiar with open law?
Sure, yeah. So open law, I think, is this initiative where they basically define a markup language for lawyers, right? So there's always this wonder, like every time I do an NDA, I was wondering, why is it doing 10,000 times this custom NDA? How is it really different? So you thought it's obvious that, like, as an engineer, I would want a markup language to define a couple of variables, like who is party A, party B, et cetera. So open law is this initiative, but it ties to the blockchain by, first of all, obviously having a testation on blockchain. It also, I guess, ties to a certain smart contract that might be a subset or a manifestation of this contract. I find this kind of initiative always really intriguing. I think there are a lot of initiatives before, but this is the latest one that seemed to make the most sense to me, that from a user standpoint, especially when you think about consumer to corporation interaction, it's really hard for them to think about they actually going to verify the code. It's much easier, however, possible for them to read a piece of the contract, especially the core components, highlight it, and then you say, okay, it has been attested or audited by a third party that said these two are equivalent. And I think it might be we're getting closer to that timing that actually might happen.
Cool. So we have a couple minutes left. Last question before we open it up to questions from the audience is, what properties do you think that the winning smart contract platforms or smart contract tech will have?
Definitely governance, definitely formal verification, definitely the ability to integrate with existing backends. I don't know if it being usable by people who aren't developers is actually a killer feature or is just nice, or if generalized applicability is, Turing completeness is a core feature that needs to be there, or if it's like something that just is useful in certain cases. Yeah, I think that kind of those 5. I wouldn't be surprised if we end up seeing, like we saw with, again, the only prior art we can look to are databases, in seeing that SQL showed up on the scene in the 80s, and now every database has a version of SQL that runs on top of it. I wouldn't be surprised if we see a standardization around languages. I don't think we're going to see a standardization around coins. I'm pretty sure there's always going to be a bunch of coins running around doing different things and experimenting for a long time.
That's another panel.
Sorry, is the question around winning qualities
of smart contract platform.
Yeah. I would highlight a few things. We talked a lot about privacy today. I think privacy is a really, really important one. The other component I think is actually, I think it's critical to a platform, maybe cross-platform as well as stablecoin. And especially if you can combine the two, right? When you have a privacy conserved stablecoin, the potential imagination is incredible, I think. When you think about today, you can put in offshore wealth, Swiss banking, you can go for the Bitcoin, but then you suffer two extremes. You have volatility problem, or you have really bad thing. If you combine these two, it's really critical. So for a smart contract platform, I would say stablecoin is, even though technically it's a high layer thing, it is really critical thing. Then you think about dApp tooling, the stuff that we mentioned about IDE and all that stuff that associated with that.
So this is probably my most contrarian position in crypto, but I think that the winning feature of a smart contract is not going to be scalability or best developer tooling. I think it's just going to be the platform that makes it easier for average people to own things. So I like to think about why I'm in this space to begin with, because there's actually a lot of noise, lots of scams, lots of bad actors in this space. But the thing that makes this space so exciting is because it's the exact right zeitgeist. Right now there's a big problem with inequality, wealth inequality across the world. And I think smart contracts are interesting because it's really trying to disrupt the notion of ownership. If it works, it means that, I think Will mentioned data, like the fact that you create data, that's going to be a part of your ownership. How do you actually have fractional ownership of real estate via smart contracts? And I think all of this, whatever platform provides a way for people to start getting ownership in the things that they're participating in, the neighborhoods that they're building, the companies that they're building, that will be the thing that makes it win. The scalability, governance, there will be a point where it's good enough, but ownership and inequality right now is not.
Cool. So we're out of time. I don't know if we can squeeze in one question or head on to the next panel. Your call.
One very quick question.
One very quick question. Oh, great. Didn't even need to squeeze it in. Awesome. Thank you, guys.
Thank you.